Yeah, so just a warning, maybe this is the same for many of the other presenters. I'm talking from home and I have a 3.5-year-old in the flat. So she might just sort of spontaneously come running in like a, you know, as though I was some sort of South Korean BBC correspondent. But, hopefully that won't happen. It'll be a joy if she does. She's lovely. Yeah, so thanks so much to the organisers for inviting me to talk. It's just a massive privilege to be part of this lineup with this super stellar cast of Humeans of various stripes. So very privileged. I hope what I'm going to do won't seem a little bit ungrateful, because I guess the sort of purpose of my talk is to try and sort of be a bit of a downer on a number of recent developments in Humeanism, at least Humean thinking about laws. So I guess I'm sort of like, the idea is to be a bit of a kind of old man and say, it was better in the old days when we just did things a bit like David Lewis wanted. So I'm going to begin by, am I still sharing my slides? Can you still see them?
Yes, although I don't see them moving. Are they supposed to be moving?
Oh, okay. Let me share them again. Resume share. How about that? Is it?
I see it.
Moving on now?
Yes.
Okay, good. Right. So I'm going to start off talking a bit about, classic Humean views about the relationship between necessity and laws, and then pithiness and laws. Pithiness being my pithy summary of the idea of a balance between simplicity and strength. The relationship between pragmatics and laws, which is the new thing in town. I'm not so bothered by that. I'm going to talk a bit about the problems that have been noticed with the traditional pithy view of laws, and then talk about a number of approaches that have proposed a revision to the original desiderata of pithiness, and by suggesting alternative desiderata in response to the problems with the canonical pithy account. I'm going to raise some problems for these kind of approaches, problems that I think cast it in a poor light, and warrant perhaps a return to the good old days when Pith was all we ever really wanted. Okay, so necessity. So everyone agrees that laws of nature have got something to do with necessity, and in a kind of Mark Lang kind of way, we can ask, are the laws necessary because they're laws, or are they laws because they're necessary? If we're Humean, and unlike Mark Lang and many others, we'll be saying something like they're necessary because they're laws, right? We see a kind of explanatory structure like this. We think the laws are some subset of the generalizations that hold of the world, and we pick them out by some criteria or other, and then we imbue them with necessity, such that we choose to hold them fixed in counterfactual reasoning. Something else that we might notice about laws of nature, and pretty much everyone will be in agreement on, I guess, is that laws of nature are pithy. They seem to be incredibly terse ways of summarizing enormous amounts of information about the world. And one can ask in a similar vein to the relationship with necessity, are the laws pithy because they're laws, or are they laws because they're pithy? And what David Lewis suggested is that we use pithiness exactly as the desiderata for picking out what those generalizations are. So Lewis says they're laws because they're pithy. So we get a structure like this. We pick out the generalizations, certain generalizations in the world because of their pithiness, or more specifically, being theorems in the system which best compromises simplicity and strength. We call those laws, and then we imbue those with necessity and hold them fixed. Okay. So I'm going to refer to that as the kind of canonical best systems account. Canonical because it was the original and has become part of Humean canon. And it's the one defined by using the desideratum of Pith as defining what the law is constitutive of the laws. Now, another feature which I guess no one will deny about laws is that they are very useful. And so again, following this trend, we can ask, are the laws pragmatically useful because they're laws, or are they laws because they're pragmatically useful? Now, we're presented with a bit of a problem. Your typical anti-Humean is going to say something like, they're pragmatically useful because they're laws. Surely we can't pick what the laws are just because we find, because of what we find useful. Right? There's something that seems odd about that. Laws have traditionally been assumed to be something objective that we go out in the world and discover, and when we've discovered them, we use them as best we can. That was the kind of old flavor. The problem is that for the Humean, that can seem like it might be a difficult thing to endorse, especially when it seems like the criterion of pithiness, for Lewis at least, was sort of plucked out from thin air seemingly. Like, why pithiness, right? And the best that he might be able to say is just, well, don't we like to summarize things very comprehensively and as tersely as possible? You know, there's this example which I think originated in his counterfactuals book of God's Encyclopedia, giving us a very kind of concise summary of the history of the world. So it already seems like the Humean is kind of committed to building pragmatics in as constitutive of the laws of nature. And what Ned Hall has done for us is he's made it seem okay to do that. Right? So what he said is, don't ask, given such a metaphysical outlook, what the laws are. Ask instead how, given such a metaphysical outlook, one might usefully draw a distinction between certain facts about the world that are in some sense distinctively appropriate targets for scientific inquiry, or datses, and other facts that are less interesting and central. For now, I simply wish to note that there's plenty of room for the view that it is in fact part fact about us, idiosyncratically about us and our peculiar human psychologies that play a role in determining the most appropriate way for us to structure our investigation of the world. How could the details of peculiar human situation not be relevant to this matter? And if so, then of course it should be partly up to us, that is partly contingent on our particular needs and limitations as inquirers, what counts as datses. So Hall is suggesting, in effect, that we just simply say, look, if you're a Humean, you should just think the laws just are the distinctively appropriate targets of scientific inquiry. And if you agree with that, then it's just perfectly reasonable to think that the laws are laws because they're pragmatically useful. Right? Within science, we have certain pragmatic needs. We go out and look for certain things that are tailored to what we want. And we just call those laws, and that's what laws are. So it's fine to answer to reject the anti-Humean intuition. Okay, so we have a structure like this. Now, Hall's response to the anti-Humean here isn't tailored specifically to making sure that the desiderata of Pith are what we maintain. Rather, he just says, look, whatever desiderata is the right desiderata to use for the Humean, we can make sense of them being pragmatically motivated. This is the kind of observation that I take to be what the pragmatic turn is. As far as I'm concerned, this is a pretty good response to this kind of anti-Humean intuition. I think it's a kind of response that a lot of people, you know, particularly what I'm going to call these revisionists, are sympathetic with too. Now comes this observation that the desiderata strength and simplicity, or pithiness, on its own may not actually be the desiderata that we want. Why is that? Well, there's a bunch of reasons, but it's been noticed that pure Pith might seem to make the laws too broad. That is, it might seem to let in too many things. If we pick out the laws on criteria of pure Pith, then it seems that we might allow these phony constants to count as laws. What are they? Well, they're numbers that are encode information about the particular state of a world at a particular time. And because they kind of have the structure of a normal physical constant, then we should allow them to go into our system, but we wouldn't think of those as being laws. Nevertheless, they are incredibly strong. They comprehensively cover a lot of information. They do so quite simply. John Roberts and Jim Woodward have pointed towards the possibility that pure Pith might imply that generalizations, for instance, about the similarity of the direction of orbits of the planets would count as a law. Because if you've got any information about the initial conditions in the best system, like a phony constant, and you've got more basic laws, then you're going to be able to derive generalizations like these. So it would be counted as a law on traditional understandings. But that doesn't seem like a law either. Ziggy Yarg and Christian Lowe have talked about total charge generalizations. So again, if you've got any information about initial conditions and you've got some basic laws, then you should be able to derive a generalization about the total amount of charge in the universe. But again, that doesn't seem like that's a law either. So that's one kind of complaint. Another kind of complaint is that pure Pith might make the laws too narrow. It might miss out some things that we do think are laws. So Woodward used the example of a complex and unusable function f that nevertheless precisely takes us from one variable to another. And he considers whether we would call that a candidate for a law or something that's much simpler, but is only able to give a kind of summary of the relationship between the two variables. And he says that it's possible and potentially is likely even on some given the right complexities that the best system understood as with desiderata of pure Pith would say that f is just too complicated to be a law, whereas that g is allowed. Whereas Woodward says surely f is the law, if anything. Another example comes from Mike Hicks, who talks about a force law, which has the kind of structure of a Taylor series expansion. So in some sense, infinitely complex, and so potentially prohibited from coming into the best system, so long as there's a criterion of simplicity there. And nevertheless, we would think in a world where that precisely captures the forces applied to objects, we would think that would be a candidate law. And then Hall has this example of fundamental constants. We do think that there are fundamental constants in our laws, but they are infinitely long, in some sense infinitely complex. If you're going to let them in, then phony constants should be let in. But if you're going to try and exclude phony constants by saying they're too complicated, then you're going to have to exclude fundamental constants as well. So there seems to be a dilemma between choosing between those two. So that's another kind of issue with pure Pith. Another issue with pure Pith is that it seems to invoke the wrong kind of strength. It's been noticed, and I think it's been drawn out most clearly in Yarg and Lowe's paper, that laws exhibit a kind of modal latitude with respect to initial conditions. And this was something that was mentioned yesterday in the talk. Modal latitude being a kind of accommodating with respect to a wide range of different initial conditions. And by contrast, the dynamics tend to be quite highly constrained. But there isn't any reason to think that kind of nuance, that kind of division between initial conditions and dynamics is something that the best system understood using criteria only of Pith is going to pick up that kind of nuance, right? Why would pure Pith make that sort of distinction, which seems important? And finally, there's this sort of general concern that the canonical best systems account using desiderata of pure Pith is too global, right? So Chris Dorst says, it's possible that the comparatively useless information about distant events will swamp out the more useful information about how things behave around here. Alternatively, it's possible that the information we care about won't get swamped out, but instead it will be condensed into a form that makes it unusable. A similar kind of complaint from Mike Hicks. the information provided by a globally strong law book may only allow informations to make predictions if they know just where in the world they are. But agents are often operating with very limited knowledge about their position in space and time. And so what's being got at here is the suggestion that pure Pith doesn't seem to capture the fact that what we want from laws, what seem to be the right things for science to target, are facts that pinpoint information, that help us use information that we can actually gain about our local surroundings and actually help us navigate our local surroundings, as opposed to just giving us some kind of comprehensive, in Chris Dawes' phrase, God's eye view of the world. Okay. So, bunch of issues for the traditional picture. This has motivated revision. Right, the suggestion that maybe we should be looking for some alternative desiderata. And here, I guess, is the kind of reasoning going on among the revisionists. Pure Pith, i.e. simplicity and strength, is likely not getting the laws right, as we've just seen. But many of the issues seem connected to a failure for those desiderata alone to provide the distinctively appropriate targets of scientific inquiry. But Hall has given us a pragmatic license to explicitly put whatever features we want from our laws into the desiderata for best system. So let's do it. And so what we get is a number of different accounts, various overlapping forms, but emphasizing different sorts of things, but they will have this sort of form. You know, they'll say, the laws are the theorems of a system which best achieves a balance, not of Pith, but maybe for Hicks, modularity. That is the ability for us to employ laws concerning individual systems independently of each other. It should achieve try as best it can to maximize the quantity of determinate instances of the laws. It should try as best as it can to maximize the detail about determinate instances. Chris Dawes has his own suggestions for what we should consider. We should consider maximizing informative dynamics, tolerance with respect to initial conditions, those two being the kind of characterizations of modal latitude that I mentioned earlier. Seems also useful to try and maximize spatial and local temporal locality, and also translational and rotational symmetry. So those two criteria really kind of getting at that idea that, you know, typically we, as agents, we just, you know, if we're floating in space, we don't know what direction we're facing in. We can't intervene on things far away from us. We want generalizations that are going to help us manipulate our local surroundings and help us use information that we have access to. So let's plug those criteria in so that when what we call laws are the things that are appropriate for scientific inquiry. And Yarg and Lowe have proposed some different criteria. They suggest, and this, I think these were mentioned yesterday, or at least some of them, that it would be appropriate for science to target generalizations which admit a certain degree of error tolerance. So, you know, small changes don't really matter. We can still make successful predictions. It'd be useful if they were admissible to partial modeling. That is, you can sort of model subsystems successfully. And it would also be useful if the generalizations were computationally tractable, another suggestion. Okay. So there's some overlap between what these authors suggest, but there's also they're kind of focusing on different things. It's not obvious that they've all got exactly the same motives at heart. Some are more focused on kind of getting the epistemology of what would be appropriate scientific inquiry right. Some are more interested in agency and action. But I'm, for the sake of this talk, just kind of lump them all together. The idea seems to be, you know, as Humeans, we should think, look, we have some pragmatic considerations about the kind of thing we want to look for. This motivates a bunch of desiderata, modularity, isolated systems, modal latitude, locality, symmetry, error tolerance, tractability. Maybe it's an indefinitely long list. It's those desiderata that help us say what the laws are, perhaps using some kind of systematization procedure, and then we imbue those with necessity and we call them laws. Okay. Now, this is not a tactic that I find immensely plausible personally, but I've struggled for quite some time to try and persuade myself of any reasons why. What I want to do is suggest 3 reasons that I think possibly reflect badly on this kind of response to the problems with pure pith. So I'm just going to take them in turn. So the first one is what I'm calling physics indifference. So I guess if we're going to sum up this problem, it's just that physics seems indifferent to us. Physics isn't about helping us. Now, this is an intuition that I think is shared by physicists and, at least traditionally, by many philosophers, not necessarily anti-Humean philosophers, but philosophers who actually do have some Humean sentiments, like, for example, Donald Davidson. He had this to say in describing what he took the project of physics to be. We don't know, and for practical purposes don't care, what would happen if there were no oxygen, temperatures were to fall below absolute zero, or there were a black hole in the closet. The more precise and general laws are, the less likely it is that we will be in a position to employ them in predicting the outcomes of our ordinary actions or the weather. But we have interests that are not practical. There are things we want to understand, whether or not we can control them, and whether or not such knowledge will serve our mundane needs. Pursuit of the truth in such cases can, in principle, proceed without the constraints of practical control and gain. In this mood, we can seek laws that have no exceptions. For Davidson, that was what physics was about. But what did Davidson know? He's just an old dead philosopher. But what about an alive physicist? It seemed like Lenny Susskind was making much the same sort of point when he says fundamental physics doesn't care that much about us. So it's this kind of attitude that I take to be sort of reflective of this idea that physics isn't about helping us. It's about finding out what the true exceptional generalizations of the world are. Now, you might think, well, if it's not about helping us, then maybe that's just going to screw the pragmatic turn in general, right? Maybe we can't even say that pithiness can be pragmatically motivated. Well, actually, it's not clear to me that when people invoke this kind of intuition of physics indifference, that they have in mind also the thought that physics doesn't care about generality. Indeed, in this Davidson quote, you can see he's precisely suggesting that physics is about looking for absolute generality. And of course, we've got famous quotes from Einstein saying, that simplicity and strength are very important. It can scarcely be denied that the supreme goal of all theory is to make the irreducible basic elements as simple and as few as possible without having to surrender the adequate representation of a single datum of experience. So there's Einstein apparently suggesting that simplicity certainly is a basic consideration, constitutive desideratum when we're theory building. And Einstein also said, the supreme task of the physicist is to arrive at those universal elementary laws from which the cosmos can be built up by pure deduction. This time, perhaps emphasizing more the idea that it is a constitutive desideratum of theory building to emphasize generality. So insofar as there is this intuition of physics indifference, it's one that doesn't seem to carry over to the desideratum of Pith. And just to really ram home the point, we might say, look, where are these analogous quotes from Einstein or whomever about the revisionary desiderata, right? Einstein, as far as I know, didn't say it's the supreme goal of building theories to try and maximize symmetries or to maximize locality or to maximize computational tractability or to maximize error tolerance. Now, of course, physicists might desperately hope that those will be characteristics of the theory. And certainly, physicists will try and develop interpretations of theories that are particularly symmetrical, or perhaps motivated by considerations of symmetry, and similarly with locality. But I think that's a different thing from suggesting that these are constitutive of the very practice of theory building in physics. So I guess what the suggestion is that insofar as it's an issue for the revisionary approaches, is that there seems to be this kind of intuition that really what's going on is something like this. We have constitutive pragmatics, those kind of pragmatics that we do think are relevant to physics. It's those that are giving us the desiderata of pithiness. It's using those desiderata that allows us to find what the laws are. And then any further characteristics are really just derivative, right? If it turns out that the pithiest generalizations of our world are ones that are symmetrical, then great. But, it's not constitutive of theory building that we look for ones that are, and it's not essential that the world be one that kind of allows the laws to be that way. Okay. So this is the first issue. Physics is indifferent to the revisionary desiderata, not to the canonical desiderata. At least if you're buying into this intuition. A different kind of issue that I want to raise concerns what I call limit case systems. So the problem here is that there are limit case systems for the revisionary desiderata. What's a limit case system? A limit case system for some feature f is a law-giving system, that is the best system for a world which we are happy to say is providing the laws, which fails to represent some feature, that feature f, to any degree. So to help us think a little bit about what a limit case system is, we might think about the limit case system for the symmetries, rotational and translational symmetries. And to help us think about that, let's think about Aristotle world. Aristotle world is a world much like Aristotle imagined it. Things tend towards an objective center, and other things, due to their material constitution, tend away from it. In such a world, if you undergo some kind of boost or movement from one place to another, you certainly can't, there's no reason to think that you'll satisfy the same kind of forces or be under the same kind of constraints. Similarly, if your orientation is entirely asymmetric, if you turn in one direction, you might be close towards this objective center of the universe. You turn in a different direction, you won't be. So now it seems plausible to me that the best system for that world would be one which outputs a bunch of theorems that are not symmetric in the slightest, right? In fact, they'd be ones that say, here's the center of the universe, and things will tend away or towards it based on their material constitution. Now, it seems that not only would that be a best system, it would be the law-giving system. It would be right to say that those kind of generalizations are the laws for Aristotle world. In that case, we'd have a limit case system for symmetry in that world. We can do this sort of trick for lots of the revisionary desiderata. So think of a limit case system for modal latitude, the desideratum of modal latitude. And now think of a world where systems just spontaneously appear seemingly at random, always in exactly the identical initial conditions, but from then on just dynamically evolve in this completely chaotic, unpredictable way. It seems to me that in such a world, it's quite plausible that the best system would be one which has generalizations which describe exactly that fact, right? It'd be one where modal latitude is just not reflected at all. In fact, it would be precisely the opposite. We'd have very precise constraints on initial conditions, but it would be the dynamics which isn't constrained. In such a case, I'd think that it would be right to call those kind of generalizations laws of the world. And so we'd have a limit case system for modal latitude. You can think of a world where the best system is one which outputs generalizations which are just completely intractable. Right? Woodward himself suggested that there might be such functions, right? Generalizations which just can't be used, but nevertheless precisely take us from would leave from one variable to another. It would seem right to think that in such a world, a best system might output theorems which are entirely and thoroughly intractable. Nevertheless, it would be right to call those the laws of some worlds, and so we'd have a limit case system for computational tractability. We can think of a holistic world where the best system is one where the generalizations are just completely non-modular. Right? It's impossible to try and predict the behavior of systems in that world using laws independently of each other. In that case, we'd have, if we're happy to call those the laws of that world, we'd have a limit case system for modularity. You might have an entirely non-local world. I'm just getting a bit repetitive now. I've only got two more. You have entirely non-local worlds where it would seem that where you might have a best system. The best way of summarizing what's going on in that world is to use generalizations which just do not emphasize locality at all. It's entirely non-local. If we think that those are nevertheless the laws of that world, then we'd have a limit case system for locality. Finally, you might think there's a world where the best system provides generalizations which are highly sensitive. That is, any small perturbation in the initial conditions just brings about radically different dynamics. In such a world, if you think that those theorems are nevertheless the laws, then what you'd have is a limit case system for error tolerance. Okay. Now, I don't know whether these worlds seem like appealing to you or like plausible or maybe even an issue, but one thing we just need to establish is we shouldn't complain that these worlds don't contain creatures like us, right? One thing is, well, they could, right? We're humans. We can put anything anywhere we like, right? If I want to dump myself with a lab coat in, the same start, different finish worlds, then, I can do that. It might be that I have to allow myself to obey slightly different rules. Maybe I don't interact with the world in quite the same way. Or maybe I just allow myself to be this isolated region where I'm not obeying the laws in the rest of the world. But it's at least possible to imagine these kind of circumstances. But even if there's something wrong with doing that, it still seems right to say, well, look, can't we just anyway ask what the laws are of these worlds, whether or not there are creatures like us in there? If you think it's right to ask that there are laws in these worlds, then it's right that a Humean account of laws should have something to say about. Okay. Now for why these limit case systems might be a problem, right? So they seem, I think, highly plausible for many of the revisionary desiderata, but arguably features which admit limit case systems can't be constitutive for desiderata for laws. Why is that? Well, at least on a kind of fairly natural understanding of what a trade-off or a balance involves, if you're trying to systematize some sufficiently complex but finite amount of data, then any desiderata that has some non-zero weight is going to be reflected to some degree. Right? I don't think any of the worlds that I described were so expansive and infinite that a desideratum that's playing some positive weight would get entirely flushed out. But nevertheless, I'm suggesting that it would be right to call the laws of those worlds ones which don't in any degree reflect the relative desideratum. So it seems like if you're admitting the limit that there are limit case systems for certain features, then at least if the relevant worlds where that's the case are worlds which are finite but sufficiently complex, then there might be an issue with trying to understand how those features could be playing a role as desideratum. A more serious issue, though, I think, is just that neither simplicity nor strength have limit case systems. Why is that? Well, let's imagine almanac world. This is a world where the best we can say about it is just simply giving a list of everything that happens. That would be a world where simplicity is just playing, seemingly being not reflected at all in the best system. Now, we can do the same trick we did with the other worlds and say, well, is that best system providing the laws of that world? And I think we have very principled reasons to say absolutely not. Right? almanac world has no laws. Why is that? Well, the generalizations that you can derive from an almanac will not make a distinction between accidents and laws, because from the almanac you can derive every generalization about that world. So there won't be a distinction between accidents and laws. But it seems to be a fundamental characteristic of describing what laws are, that we make a principal distinction between generalizations and accidental generalizations of laws. But there couldn't be any for such a system. And so there's a principled reason why there couldn't be a limit case system for simplicity. We can do the same with strength. Imagine logic world, where the best system that we can provide for that is one which doesn't reflect to any degree strength. The thing that it features in this best system are just the laws of logic. Well, logic world has no laws, right? That might be the best system we can give, but it wouldn't be a system that's giving us any laws. Why? Well, because the laws of logic aren't laws, right? They're not physical laws. Physical laws are, Humeans think, contingent. So Humeans shouldn't allow that there are limit case systems for strength or simplicity. We've got principled reasons to say so, but we don't have principled reasons, it seems, to deny them for the other desiderata. And so we should really accept that there are some. So there's a massive distinction then between the kind of canonical desiderata and the new. So second problem, there are limit case systems for the revisionary desiderata, not the canonical desiderata. The last problem that I want to mention is one of antagonism. The revisionary desiderata, I claim, can be antagonistic. Revisionists have motivated their desiderata by attention to our limitations, right? You get quotes, for example, from Hicks. He'll say, agents are often operating with very limited knowledge about their position in space and time. Laws must be discovered empirically by limited agents operating locally. And, oh, this is missed out, I hope I can still read it. Jürgen Loew said, a system has to allow us to make the relevant predictions from the available input without being too demanding on our capabilities for storing and processing information. So very much centered on, in fact, this was Hall's initial idea, idiosyncratically on us seems to be the idea, right? We can really just look within our meager, crappy human abilities to decide what the sort of desiderata should be. But is it really right that our limitations should be relevant to the laws in all worlds? I mean, this is something that I sort of was trying to press in the previous problem, but just to really make the issue a bit starker, let's consider a new world, homogeneous world, where everything always and forever is just an instance of the same natural property. You could call it redness, or it could be some value of charge. In such a world, it wouldn't seem like it makes sense to talk about a temporal dimension as contrasting with a spatial dimension. Nothing's moving. There aren't really any identifiable systems. Rather, it's just everything always is the same way, right? Now, it seems like maybe there's laws in that world, right? The law that for every and always things are red. But the real issue that I want to press in this instance is that it doesn't seem like our limitations and the fact that we can't manipulate things that are far away from us, or that we can't often tell what direction we're pointing in, or that we're, computational attractability issues. Should those kind of issues be playing a role in what we think the laws are for such a bizarre kind of a world? It's not obvious to me that they should be. Perhaps a more serious issue, though, is that I think it's wrong to think that our limitations are the same in all worlds. So let's go back to the Aristotle world. If it turned out that Aristotle was right, there really is an objective center for the world, then what we'd be talking about now is the fact that we can very easily tell what the asymmetries are, right? It's not the case that we are somehow intrinsically and in all worlds unable to tell what direction we're facing. No, in fact, it's very easy to tell what direction we're facing. The center of the world is that way, right? And the opposite is that way. I just know that because I live on the Earth, and the Earth's at the center of the universe. And you might think similar things for other kinds of desiderata. So, for example, in a non-local world where there's rife non-locality, then it might be very easy to manipulate things that are far off. And there's no reason to think it would be easier to manipulate things that are close to you than further away. And in fact, that's something that Mike Hicks has seemed to have conceded in a more recent paper with Demarest. They say tools to measure non-local correlations could themselves be non-local. And indeed, that seems entirely right. It seems that our abilities as agents, what we're able to do, isn't something that we should build in constitutively to what we say the laws are for any world. Rather, what we're able to do is very much a matter of what the laws are. But that seems to get things entirely the way around that the revisionist doesn't want them to be. So there's two issues here, right? One is that the revisionary desideratum can seem antagonistic towards identifying the distinctively appropriate targets for scientific inquiry, because it doesn't seem like our limitations necessarily are relevant in all worlds, but also it seems like our limitations will vary. So if we hold fixed particular desiderata that are motivated by contingent limitations, then we're going to get antagonism when we start thinking about other kinds of worlds. But the second kind of issue is that there seems to be an answer to what makes revisionary desiderata antagonistic or conducive, right? Now, even the fact that there is an answer at all is a problem, right? Because the revisionist is wanting to say there shouldn't be an answer to why they're antagonistic or conducive, because I'm just stipulating that's what the laws are. They're the laws that have those desiderata. But if the fact that there's an answer means that there's a question, which means that something explains why they're antagonistic or conducive, and that might concern us already. But I think maybe what's more concerning is the fact that the answer, quite plausibly, is that the reason some desiderata are useful or not to giving us what the distinctively appropriate targets are is that the pithiest system exhibits them as a feature, right? So what's the pithiest system of this world? Well, it's a world which just happens to chuck out a bunch of theories that are symmetrical and provide quite rife locality and quasi-isolated systems and a lot of computational tractability and so on. Go to Aristotle world, it's not like that. The pithiest system won't give us that. So, but it seems like then it's Pith that's explaining why the revisionary features are even conducive or even capture an aspect of what we want to say the laws are at all. So it seems really that Pith is doing all the work. Okay. So, third problem, the revisionary desiderata, but not the canonical desiderata, have the potential to antagonize our search for the distinctively appropriate targets for scientific inquiry. Okay, I'm guessing I'm due to stop at 10 past. I'll try and do this last part fairly swiftly. So, I mean, so far, I hope I've sort of at least taken you along with me and sort of persuading you that at least I have reasons to be, to think maybe the revisionary turn isn't quite approaching things the right way. Obviously, it's incumbent on anyone who, like me, who wants to say that, to say, well, what else are you going to do? Yeah, there are all these problems with pure Pith. So I have to try and find a way to address those problems in a different kind of a way. And I just, in closing, want to suggest some ways we might do that. So 3 different choice points of what we as Humeans can say, using only pure Pith as our desiderata, for how to maybe duck and weave away from these problems. So the first is with simplicity. We can ask, what do we mean by simple? Well, I guess I just first want to add another thought, which is insofar as the simplicity worries about Woodward's complex function F and the Taylor's law, Taylor world law, and physical constants is an issue, then isn't it an issue for all of us? In fact, as far as I understand, none of the revisionary best systems accounts suggest removing simplicity. I think Mike Hicks has suggested we give it less weight, but if it's got any weight at all, then there's going to be some threshold beyond which some kind of notion of there's going to be some notion of being too complex. So I'm not quite understanding how revisionary accounts hope to avoid those issues anyway. But anyway, it's okay, because I think we have a different way to get around these issues. And that's to observe, firstly, it's typically that simplicity has been taken to be a matter of syntax or expression of individual axioms, right? And so Lewis talked about linear functions being simpler than quadratics, and the number of quantifiers being capturing the degree of simplicity of a theorem. But what I think humans should say is instead that we should stipulate that simplicity is a matter of systems themselves, i.e. the number of non-disjunctive axioms. Right? More non-disjunctive axioms makes for a less simplicity. Disjunction in your axioms makes for less simplicity. Okay, if that's the way you measure simplicity, and you don't say anything about how complicated axioms themselves are, then as long as they're non-disjunctive, then Taylor's world law can be counted as a law. Woodward's function f deserves a place. So fine. Obviously, that's not going to stop phony constants from getting in. So what are we going to do about those? Well, now we move to a different kind of choice point. And that's thinking about what gets held fixed. We must grant, I think, that there are probably many best systems tied for best, varying in only non-disjunctive facts. The idea here is that we've got to get out of our minds the idea that systems, there needs to be one that sort of stands out best, or a few that are kind of tied. Rather, we should just think, look, there are likely to be infinite best systems. But what we're interested in is the things that we need to hold fixed, are the things that appear in all of them, right? And I think it's likely that we can, or it's plausible at least, that laws and things like the past hypothesis will appear in all the best systems, tied best systems for our world. But each phony constant will only appear in some. Why is that? Well, because the phony constant encodes the information about a particular state of the world at one time can be substituted for a phony constant that picks a different state. And that can be substituted for one that picks another state. So there's no reason why one particular phony constant needs to feature in all the best systems. So there'll be a bunch of best systems individuated by having different phony constants. So the phony constant won't appear in all of them, but the laws in the past hypothesis will. So that's what decides what we hold fixed. Humans should stipulate we hold fixed only what gets into all the best systems. Okay. So that solved our phony constant problem. What about spurious generalizations like planetary orbits and so on? Now we move to the third choice point, lawhood. What should we say gets called a law? Well, the first thing to say is that if our criterion for what we get to hold fixed isn't the same as our criterion for what we call lawhoods, then it's not incumbent on us to say that the past hypothesis is a law, which is something that I think some people rightly find a little bit strange. Right? We want to explain why we hold it fixed. And I've given you a reason for that. We hold it fixed because it features in all the best systems, but we don't need to call it a law. Why not? Well, it's not a generalization. Right? But I think further, humans should limit the laws to the theorems of axioms which are generalizations, right? So not only are the laws generalizations, but they're theorems of axioms which are generalizations. That is, we shouldn't call anything a law that's got any initial conditions worked into them in their derivation. If that's right, then planetary orbit generalizations and total charge generalizations won't be laws. Why? Well, because both of them require at some point that initial conditions have got in so that we can derive these generalizations. Okay. So that's a sort of sweeping attempt to knock out the issues in a way that's conducive to pure Pith. I just want to close with responding to another worry that I feel like might nevertheless be locking around in revisionists' minds, or those who sort of are concerned about the canonical system. And this is the worry that maybe a God's eye competition judged based on pure Pith would have to be lucky to return the distinctively appropriate targets of scientific inquiry. So firstly, well, I've argued that's the best we've got, right? So tough luck if it's lucky, because that's all we can manage. But actually, but there is this worry, right? And I think Chris Dorst has maybe said it most clearly. He claims that its potential for purely pithy best system competitions, provision of, for example, Markovian laws, that is ones which admit of a sort of temporal locality, would seem to be merely a stroke of luck, a convenient accident, as it were. So I think insofar as this is a worry that, you know, if we rely on a best system where the desiderata is only pure pith, then we're just sort of got this worry that it'll only just by chance get the laws right. Well, I don't think that's the right way to think. Obviously, luck is a matter of what the laws are, right? There's no sense in which, you know, it so easily could have been otherwise, because exactly what could have been otherwise is a matter of what the laws are and what gets held fixed, right? There's no sense to be made from some desiderata for best system judging the laws correctly by luck. If they do it, then they do it as robustly as anything could. Okay, so that's my defense of pure pith and my suggestion that maybe it was perhaps never necessary to take the revisionary turn in the first place. And I'll end it there. Thank you.